What's going on, guys? Let's do this problem right here. The question is asking calculate the total work done in this cycle, right? So let's see how we can do this one. To find the total work, what we can do is we can add the processes. Like we have one process, two process, three process. So let's say this is 1, 2, and 3. So the total work is going to be equal to W1 to 2. W2 maybe putting an arrow make it very clear, right? So 1 to 2 plus W2 to 3 plus W3 to 1, right? So that's going to be the total work. So let's look at what happens in the W1 to 2. If you look at this one, this W1 to 2, this is an isothermic process because volume is constant. In both case 1 and 2, it's 20 liter, right? So volume is constant. So whenever we have volume is constant, the work is always 0. So that's a generic thing. And if you want to clarify this one with various things, like we use W is equal to P delta V equation. You can say V final volume and initial volume are same. So delta V is going to be 0. So P times 0, that's going to be 0. Or if you draw that graph alone, like isothermic graph alone, usually we calculate the area below whatever the line we draw, right? So since this is a vertical line, there's no area below this one. So in that way also you can clarify this one. So for isothermic process, work done is always 0. So this is going to be 0. Let's look at the W2 to 3. This is an isothermic process, right? For whenever we have isothermic process, we use this equation nRT ln V3 over V2, right? So you may wonder why don't we use P delta V? If you want to know how did we derive this one, let's see. I show you. So here what I can do. So here, if you notice this one, this is not decreasing like a straight line, right? So here we use the calculus. If you study calculus, you know that we can integrate. W is equal to integral, let's say this is going from 2 to 3, right? So this V2, V3, P, dV, right? If I do the integration, that's going to give us the work. So instead of writing P, what I can take PV is equal to nRT, and P is equal to nRT divided by V. So that's what I'm going to substitute instead of this P. So here what we get is integral V2 to V3. Instead of P, I plug this value. That's going to be nRT over V dV. Since we have dV right here, everything except V is going to be constant. So I can move everything except V to the front, right? So this is going to be nRT integral V2 to V3, and this is going to be 1 over V dV. And we know that whenever we have 1 over V, if we integrate this one, that's going to be ln V, right? Ln V. So here we can write nRT ln V. If I do the integration, that's going from V2 to V3. Now if I plug this one, so this is going to be only for this part right here, right? So if I plug this one, V2 instead of V, V3 instead of V, this is going to be nRT ln V3 minus ln V2, right? So that's going to be it. And also in logarithm, if you subtract, that's going to be equal to dividing each other. Like if it's ln V3 by V2, we can directly say ln V3 by V2, same thing. And if we multiply, we add. So that's how it works. So what we can do, instead of writing like this, we can say nRT ln V3 by V2. So that's how we derive this equation. So in isothermal process, this is going to be like this, right? So this is going to be the equation we are going to use because it's not decreasing straightly. That's the reason. So let's look at 3 to 1. For 3 to 1, if you look at this one, this is an isobaric process because the pressure is constant. So whenever we have isobaric process, we use P delta V. We can use for that one, this one for that one. So this is going to be P delta V right here. And let's see how we can calculate these all values, right? So here delta V is going to be, let's mention that one, like it's going to be 3 to 1. So it's 3, 1. Okay. So here, we know this one is 0. For this one, do we have all the information? Do we have N, that's 1 mole, or we know that there's a gas constant, T. For this one, since isothermic, the temperature is going to be same, right? But we have to know T2 or T3, one of it, to calculate that one. So we have to calculate, because we only have T1, we don't have T2 or T3. So we have to calculate that one. So let's see how we can find that one, right? So here, oh my god, what happened? Okay, so what I'm gonna do, I'm gonna erase this one. This is all we have to know is this equation, right? Okay, now let's continue this one right here. So let's see whether we can use PV is equal to nRT to find this T temperature, right? So here, if we want to use PV to equal to nRT, we have to know the pressure at 203, volume nRT, right? So let's look at T2 or T3. Okay, let's do T2. We know the pressure at T2 is 2 atm, and volume is 20 liter. Mole is 1 mole. We can calculate this one using that one. So T is equal to T2 is equal to PV over nR. So if we calculate T2, that's going to be same as T3 because it's an isothermic. So here pressure we can put 2 atm, and then volume is 20 liter times to convert this one into joule. Because if you notice, we have 1 mole times R is going to be 8.31 joule per mole Kelvin. This one, the mole cancels, but to cancel this joule, we have to convert this one into joule, right? Because we want the final answer in Kelvin. So what whenever we have atm liter, to convert this one into joule, we multiply that one by 101.3 joule per liter atm, right? In this way, liter atm cancels, and you will get the answer in joule. Then you cancel this joule together, and mole cancels, you get the answer in Kelvin. And if you plug this value in calculator, you will get 487.6 Kelvin. So that's going to be the temperature too. So now we can plug that value. And do we know the V3? V3 we know that. V2 also we know. So we can plug that value and calculate this, right? So let's do the calculation. So this is going to be 0 plus N is 1 mole. R is 8.31 joule per mole Kelvin times 487.6 Kelvin times log V3 over V2. That's gonna be V3 over V2, so 40 over 20, right? 40 over 20. Here we don't have to worry about the unit because both of them are going to cancel, right? Then we have P delta V for the third process. That is 1 atm. P is 1 atm, and then delta V. So V final minus initial, 20 minus 40. So this is going to be 20 minus 40. That's going to be a negative answer, and this is in ATM liter, right? To convert this one into joule, we have to multiply this one by 101.3 joule per mole, ATM liter. ATM liter. So in this way, ATM liter cancels. We get the answer in joule. So if you plug this one in the calculator, you will get 2,809 joule. Minus, if you plug these things in calculator, that's going to give you 26 joule, and finally you will get 783 joule. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.